All right, well, this is my second time recording this because the first time I didn't turn my microphone on, so hopefully everything goes smoothly this time. So today, you guys are going to be learning about inverse relations. Relation is just kind of like a function, if you don't remember from Algebra 1. But we're going to be learning about how to take basically the inverse of functions. An inverse is kind of like flipping the function or making it work backwards, okay? So what does this mean? All right, so the inverse of a relation R, so R stands for relation, is going to be written as R prime, okay? So R, if you see that prime, that's where you put the inverse, okay? And the inverse of a relation maps all the output values to the input values. So it's the opposite of what a normal function does. You would put in the output and you would get out the input, okay? And that will create a new relation. And if the inverse of a function is also a function, then we say that the original is a one-to-one function. Okay, that's just a piece of terminology that you need to know. It means you have a function, you take the inverse of that function, and you get another function that's a one-to-one function, okay? So what are you going to have to be doing? All right. Well, there's three different types of problems. The first type of problem is you're going to be given a number of points, okay? And the first thing you want to do is say, is R a function? All right. And if you don't remember what a function is, a function takes every input and gives it only one output, okay? So we have 1, 2, 3, and 4. Every input only happens once, which means they all just have one output. So this is a function, okay? Now we want to write the inverse of the function. So the inverse of a function takes all of the inputs and the outputs and it switches them places, okay? So 1, -2, that would become -2, 1. And then 2, 4, that would become 4, 2. 3, -1, that would become -1, 3. And then 4, -2, that would become -2, 4. So this would be the new function. Now we want to check, is R prime a function? Well, if we look at our inputs, we have -2, we have 4, we have -1, and we have -2. So, -2 repeats twice, which means -2 has an output of 1 and an output of 4, which is not allowed. So R prime would not be a function. And if R prime is not a function, then R is not one-to-one. The only way for R to be one-to-one is if these are both yes. So B, you guys can pause the video here, try B on your own, okay? All right, next thing you're gonna do is look at a table, okay? You're gonna verify if the two relations are inverses. So all you're saying is yes or no. All right, so you've got two functions, you've got f of x and g of x. Are they inverses of each other, okay? So what you're gonna do, you're gonna look at it. So we've got 2, 4, all right? So 2, 4 turns into 4, 2, all right? So again, the input and the output has swapped places. So that one works, so that's good. We've got 3, 9, and that becomes 9, 3. That one is also good. We've got 4, 16, which becomes 16, 4. That is also good. We got 5, 25, and that becomes 25, 5. So all four ones work, which means yes, these functions are inverses of each other. And we would just put yes. If you want to look at one that doesn't actually work, okay, here we've got 0, -1. That goes to -1, 0. So that one does work. But if any of them don't work, then it's not an inverse. So here we have 2, 0, which goes to 0, 1. So that one is not good because it would needs to go to 0, 2, right? They're not staying the same. So this one would be no. And the last thing that you're going to do is checking with a graph. Okay, now the graph is probably the hardest one to do. In order for graphs to be an inverse, it kind of explains it here, but I'll just explain it again. You need to draw this line y equals x. Okay, can't really get it to be perfect, but whatever. So all the points are going to mirror across that line. So if I was going to make the inverse of these dots, I would put a dot right there. I would put a dot right there, put a dot right here, and I would put a dot right here. Okay, So this is, and that's what this kind of shows. All the points are being mirrored across the line y equals x, and so then the inverse, they end up on the other side of that line. So the line y equals x is the diagonal line through the origin, okay? And the thing about the line y equals x is it goes up 1 over 1. So when I'm drawing my line, I want to try and make sure, can't get it correctly, you want to basically make sure that you start at the origin and then you go through like that. So you want to go through these spots that are like 5, 5, 10, 10, right? I'm going up 1 over 1 each time, all right? And if the two lines that you have are directly mirrored across that line, then the answer is yes. And if I was in class, I would kind of tell you to like pick up your iPad and kind of turn it, but it's kind of hard to show that here. This one is yes, all right? If you look at it, all the lines at every spot are the same distance apart from each other. It's kind of like everything is mirrored if you look at it that way. So this one is yes, okay? If we come over here, this one is also yes, all right? These two graphs, they're kind of loopy and they're kind of turning, but they stay across from each other. So in the beginning, black goes on top and it's just barely above. Red goes on top and it's just barely below. And then black curves off this way and red curves off that way. So again, the lines are staying perfectly across the line from each other, the same distance on each side. It's like a reflection, like if you think in geometry. If it's reflecting over that line, then they are inverses. So this one is also yes, okay? If we come down here, here's an example of one that will be no, okay? So if I draw our line y equals x here, and I'll draw it both ways, should be very clear that the red and the blue lines are not mirrored across this line that I just drew. Like if we look above, both lines are above the line. If they were inverses, we would expect the blue line to like be kind of somewhere like that. So this one is no. And then the last one is a little tricky. You won't have one like this on your practice. I just wanted to talk about this in class, but this last one is actually yes. The reason for that is you have the red line going that way, and then you have the black line going in the opposite direction up that way. So they kind of are mirrored from each other. They're going just the exact opposite directions of each other on either side of that line. So this one is yes. So what you guys are going to do for your homework, you're just going to answer these questions that are like basically the exact same questions that we did above. So you've got these ones with the points. You've got these tables right here. You're just going to say yes or no and why.
Good afternoon. We do have a couple announcements.
We're getting interrupted right here. Then you've got these graphs, and you're also just going to say yes or no. So if you have any questions, you can wait and ask me on Thursday.
And bus 106 will replace 118. New month tomorrow. Let's make sure we get it started off well. End of the 9 weeks is fast approaching. Good luck to anybody performing or competing. Have a wonderful evening. Go Jags.
All right. Thanks, Mr. Hamilton. So if you have any questions, you can either wait and ask me on Thursday or ask a classmate who might be able to help you, or you could just shoot me a Canvas message if you want. But that's it. I hope everything goes well, and I hope you all have a great day.